Hey guys, what's up? All right, let's start 2.1. We're not doing all of 2.1. We're just doing part of 2.1. We're going to finish it tomorrow. So you might remember that I'm limited in time on these videos. So I'm not going to read through these. This is all really pre-algebra review for the most part. Pause it here and write this down if you didn't print this, or get this file from Canvas and write it down. We all know function notation. I'm not going to discuss that either. So for domain, I do want to write some things down for domain, because domain and range are something that people struggle with regularly. So for the time being, we're not going to be talking about trig functions. We're not going to be talking about logarithmic functions, exponential functions, things like that. When we do, we'll talk about the domain of those. But for the time being, we're going to talk about domain in the context of either fractions. So what do we know about fractions with regard to domain? The denominator cannot equal 0, okay? And then the other thing we're going to talk about for the time being is radicals. So particularly radicals with an even root index. What does that mean? The root index is like square root, cube root, fourth root. So square root has a root index of 2, cube root has a root index of 3, fourth root has a root index of 4. So odd root indices, we can take cube roots and fifth roots of negatives. For example, the cube root of -8 is -2. But with even root indices, we cannot take roots of negatives. So for example, the square root of -4 does not exist in the real number system. It's imaginary, right? So when we're talking about domain, we're talking about real numbers. So what's called the radicand, the thing under the radical, has to be greater than or equal to 0, because I can take the square root of 0 or the fourth root of 0, right? Okay, so let's start with I think the questions are going to be pretty easy on this one because it's a pretty easy topic. So let's start with this one. First question, is this function a fraction or a radical? Okay, everybody got that right, right? The answer is no, it is not. So for the context of what we're talking about in chapter 2, if it's not a fraction or a radical, then the domain is all real numbers. So all real numbers. There's actually a symbol for that. It's in a textbook, it would be a bold R, bold and capital. So the way that we write it on paper is with a double line to kind of indicate that it's bold. But I want you guys to practice writing it in interval notation. So all real numbers means from -infinity to positive infinity. I'm going all the way to the left and I'm going all the way to the right forever and ever. Okay? So that's it. All right. Down here. Let me cover that up. In this example, is the function a fraction or a radical or neither? Like I said, the questions are super easy because it's a pretty easy topic. So, because it's a fraction, a rational function, that's all that means. Rational function sounds a lot scarier than fraction, but rational function just means a function that's written as a fraction. Because it's a fraction, look directly above. I'm not going to show it to you. What is it that needs to happen? Okay, so the denominator is not allowed to equal 0. The numerator is allowed to equal 0. I am allowed to have 0 over something. For example, 0 over 4 equals 0. But if I have a 0 in the bottom, it's undefined. Okay? So, you could move the 4 over and take the square root of both sides. I'm going to factor because I think we need practice with factoring, and I also worry when people take the square root of both sides, they're going to forget the plus or minus. So this is x cannot equal -2 and x cannot equal 2. Okay? And just so you see right here, when you have a rational expression, you need to be careful with the denominator. So those of you that printed out these notes basically got the answers to the last question or two, right? Okay, so this is what's called set notation. It's actually, set builder notation is actually a little bit even more formal than that. And I don't like formal. Set builder notation, we do a bracket to represent a set of numbers. A set of numbers is just an arrangement of numbers. And we say, like, x is an element of the real numbers such that, right? These symbols are scary. X is an element of the real numbers such that, that's what that says right there. X is not equal to -2 and x is not equal to 2. That's very formal. That's got scary symbols. I don't like that. So instead, I want to practice writing it using interval notation. So here's my suggestion if you've never written anything like this using interval notation before. First, draw it on a number line. So I want every number in the real number system except -2 and 2, right? So if I was drawing this, the only numbers I cannot use are -2 and 2. That means I want everything else. So now, do you remember what it means for the arrow to go that way forever on a number line in terms of interval notation? So that would be, I'm going from -infinity, right? I want all the numbers over here. I'm going to keep going, keep going, keep going, keep going, keep going until I get to like -2.000000000 forever 1. So I don't want to get -2, but I do want to get -2.1 and -2.01 and -2.001 and so on, right? So that's how I do that. I do a parenthesis, which means the -2 is not included, but I'm getting very close to -2, okay? And then this is a union symbol. It just means together with. It just means this plus this plus this, not literally adding, but like this is the domain. So I don't want to include -2, but I do want to include -1.99999999999, right? So then I go like this, -2. That's saying don't include -2, but get really close to it. And I want to keep going, keep going, keep going, keep going, keep going, including these numbers until I get to 2. Again, I don't want to include 2, but I do want to include 1.999999999 forever, right? So I put a parenthesis instead of a bracket. Remember, a bracket means included. A parenthesis means not included in interval notation, okay? And then from here together, so this all together makes the domain. I want to start at 2.1 and 2.01 and 2.001 and 2.000000001 and so on. But I don't want to include 2 because 2 is going to make that denominator equal to 0, and then it's going to be, the expression's going to be undefined. And I want to go all the way to the right forever and ever, okay? So that is a little, probably going to feel a little bit complicated, but I want you to practice writing it that way. The answers in the back of the book are going to be in set builder notation. I want you to practice writing all of your answers in interval notation. That's what I'm going to ask for on the quiz and test. So practice it on the homework. Okay. Last thing. No, 2 more, sorry. So, easy question. Does this include a fraction, a radical, or neither? Okay, and then another easy question. What do I need to look out for with the radical? Okay, so the radicand, the thing under the radical, this is called the radicand, has to be greater than or equal to 0. Solve. Oops, I almost forgot my negative. So subtract 4 from both sides. Red alert, red alert. Why am I saying red alert? Dividing by a -3 means flip the inequality, right? Whenever I multiply or divide by a negative, I have to flip the inequality. If nobody's ever shown that, why that is true to you, let me know in class one day and I'll show it to you because it's kind of cool. And it's super easy. Okay, so P is less than or equal to 4/3. Some of you can write that using interval notation without a number line. That's totally fine. If you don't feel comfortable with that, 4/3, right? 0 would be somewhere over here. Less than or equal to, so filled in dot, yeah. And then less than goes left. So then I just need to think about this in interval notation. So going left forever and ever and ever means I'm going to negative infinity. From negative infinity, we always think of it from left to right. Everything we do in math, we're reading it like a book. So negative infinity is way out to the left, and we're still including all these numbers, we're still including all these numbers, we're still including all these numbers. We're even including 4/3, but we're not including anything over there. So that's the domain and interval notation. And again, the back of the book is going to give you set builder notation. I want you to practice this. This is what I'm going to ask for on the quiz or the test. Okay. And then you'll see it says right there. With square roots, actually any even root index, you always want the radicand to produce a non-negative result, meaning positive or 0. Non-negative means positive or 0. Okay, this is the last example. So, do I have a fraction, a radical, or neither? All right, so I have both a fraction and a radical. So, the fraction. The denominator is not allowed to equal 0. This is from the fraction part. The radical, it's an even root index, right? It's a square root, which means that's a 2. The radicand, the thing under the radical, has to be positive or 0, greater than or equal to 0, okay? So this one is saying x can't equal 5 by just adding 5 to both sides. If I solve this one, I'm not dividing by negative, I'm dividing by 3. So I don't flip the inequality. Okay, less than or equal to -4. So now I need to figure out how to put these two things together. These both have to be true. Did I say less than or equal to? I think I said less than or equal to. It's greater than or equal to. So both of these things have to be true. So I'm going to draw a number line. I'm going to put -4, there's a 0, and then 5, right? I'm going to do this in pencil, and you'll see why in a second, assuming I can find my pencil. Crash and burn. Okay, so can't equal 5, open circle, right? Can't equal 5. That means all the numbers on the number line except 5. Also, though, greater than or equal to, okay, greater than or equal to filled in circle, right? Greater than goes to the right. So that would be that. But what did I just do? I just filled in the can't equal 5. So I need to get rid of that. It cannot equal 5, and it has to be greater than or equal to -4. So it's going to look like that. So if I'm reading my number line from left to right, the first spot that I have any kind of shading is at -4, and it is a filled in dot, so I can include it. I'm going to include everything from -4. I'm including, but then at 5, I don't want to include it. I want to include 4.99999 forever, but I don't want to include 5. And then to the right of 5, I want to include 5.1 and 5.01 and 5.001 and 5.00001 and so on. So this tells me I can get very close to 5, but not actually 5. And then I want to go to the right forever, which means I'm going to infinity. Good? Okay. And then these notations, this is the formal notation, this is all it means. So if you have an F and a G and it asks you to do this, just combine like terms. If you have an F and a G and it asks you to do this, make sure you distribute the negative or the minus sign to all the stuff that is in G and then combine like terms. This might turn into like a foiling problem or something like that. And then this might turn into a factoring problem where you simplify whatever F and G have in common. Okay, that's it. I'll see you tomorrow.